Now we will discuss other properties of matter, right? Earlier we discussed matter has mass, matter has volume, and matter is made up of particles, and properties of particles of matter we have seen. Now let's see some other properties of matter, right? The first property, let's see, it's a physical state. Physical state, right? It is one of the physical properties of matter. What is meant by physical properties? The properties that can be identified without changing the composition of matter are called physical properties. So here physical state is one of the physical properties of matter, right? Physical state, the appearance, how does it appear, right? Physical state, matter exists in three physical states. They are solid state, second liquid state, and third one is gaseous state, right? Solid state, liquid state, and gaseous state. So these three different states. For example, we'll see examples in solid state. Let's say pen. Pen is a solid. We'll understand why I consider it as solid. You know, we can identify, right, in our room what are the different states of matter. Any solid, you say your book is a solid, your pen is a solid, right? Your table is a solid. There are many solid things, but why are they called solids, right? We have to look into properties of solids, liquids, and gases. Let's see. Liquids. Any liquid, the most common liquid is water. Gaseous, the most common gas is air, etc. Like there are many other, not just one, right? So matter exists in different physical states. So physical state is one of the physical properties of matter, right? Matter exists in solid state, liquid state, gaseous state, like pen exists in solid, water and air, like this in liquid state and gaseous state. And now this is one property, physical state. Now let's say next shape is another physical property. Shape of matter, okay, right? Coming to the shape, you know, there are different shapes. I'm not going to the shape of individual matter, right? So broadly, what different shapes, different states of matter we have. Shape, okay. If we go with solids, okay, solids, do solids have a definite shape? Like this pen, what is the shape of pen? We can say cylindrical, right? What is the shape of ball? Spherical, we could say shape of solids. Solids have, because solids have a definite shape. Solids have definite shape, okay. Coming to liquids. What is the shape of water? Can we say? No, we can't say, right? Because liquids do not have definite shape. So let me write liquids have no definite shape. Liquids have no definite shape. Let's say, for example, I take few ml of water. Few ml of water I'll take, right, into the test tube. Let's say into the test tube. Now the shape of water. What is the shape of water now? It's a cylindrical, like test tube. Now if I transfer this water into another container, like let's say this is called conical flask. It's called conical flask, right? If I shift the same water into conical flask, this gets the shape of the conical flask, right? If I can shift this water into any other bottle, let's say into other bottle, if I take a bottle like this, right, and this water, the same amount of water gets the shape of the bottle, right? So water is a liquid and that has no fixed shape. Its shape changes according to container in which it is stored, or the shape of liquids. Liquids do not have fixed shape. They takes the shape of its container. No definite shape. Okay. Then coming to gases. Gases like air, they also do not have fixed shape. Gases do not have a fixed shape or a definite shape, right? But why solids have definite shape, liquids and gases do not have definite shape? This is an important point, an important question for board exams. Why do solids have fixed shape? Why not liquids and gases have no fixed shape? Okay, why not they have fixed shape? Okay, why not solids have fixed shape? Let us understand, let us try to understand the reason for it. Why do solids have fixed shape whereas liquids and gases do not have fixed shapes, right? Let us see. If I take a solid, this is, let's imagine this is a solid, this is a solid. This solid is made up of tiny particles. Let me draw the particles. These are the particles. Each circle is representing a particle of solid. Each circle representing particle of solid, and you can see in this picture these particles have no spaces between them. So intermolecular spaces are not present, or if they present, the spaces are very least. So I write least or no intermolecular spaces. No intermolecular spaces in solids. Why do they have no intermolecular spaces? Because they have very strong intermolecular forces. They have very strong intermolecular forces. So now you see each particle of solid is attracted with other particles very strongly, so that they are attracted very strongly and they are very tightly closed, where very closely packed, very closely packed within the solids, right? As a result, because of very strong attraction forces, they are very closely packed, and they do not have intermolecular spaces between them. Because of these strong forces, particles cannot move, and there are no available spaces for the particles to move, because as a result, particles cannot move and they possess fixed shape. They possess fixed shape. I hope you understand, right? The reason. Particles are attracted by strong attraction forces. They have no spaces to move. So the particles, they cannot move. They just vibrate their positions. They only vibrate at their positions, but they cannot move from one place to another place. As a result, all solids have a fixed shape. Now coming to liquids. Why not liquids have fixed shapes? Because the particles of liquids, if you see, they have some spaces between them. Okay, they have some spaces between them. This is, imagine it is a liquid substance where particles are arranged. Can we see the spaces in liquids? We can't see the spaces in liquids, but we can understand. By using an activity, let us also understand how can we conclude that liquids have spaces between them. So liquids have small spaces between them. There are moderate spaces. There are moderate or less spaces. That spaces, we say intermolecular spaces, are present between them. You can see the gaps between particles of liquids. There are the spaces, less spaces are present between liquid. Why less spaces are present? Because there are moderate attraction forces, moderate intermolecular forces are present, where in the case of solids, the attraction forces are very strong, and compared to liquids, the attraction force is little less, and because of less attraction forces, particles are attracted. Particles can move from each other, and creating some spaces between them. Because of these spaces, right, within these spaces, molecules can move. This particle, if you see, this particle can move freely? Yes or no? When particles of matter can move, available spaces are there. But as a result of this motion, right, allowed movement, free movement of liquid particles, liquids do not have fixed shape, do not have, okay, what? Fixed shape, right? Now, liquids do not have fixed shape, solids have fixed shape. Now, how about gases? Let us imagine this is a gas like air in which the particles are far from each other. They are far from each other. Why they are far from each other? Because the large, like, very weak, least or no intermolecular forces. The intermolecular forces are very weak or least or almost no forces present between attraction forces present between particles of gases. Because of no forces, the particles are free to move and creating large intermolecular spaces between them. So these particles have large available spaces, so they can free to move in any direction. As a result, these gases also do not have fixed shape. Okay, so shape of liquids and what gases is not constant, and it changes according to the container in which they are stored, right? Whereas solids, they have fixed shape, right? You understand? So solids have fixed shape, liquids do not have fixed shape, gases do not have fixed shape because of the intermolecular forces. In case of solids, strong, liquids, moderate forces, and gases, least forces. Because of this, in solids, no free spaces. In liquids, moderate spaces. In gases, large spaces are present. Because of no spaces, movement is not allowed. So they have particles are at rest mostly, like they just only vibrate their mean positions, so that particles like solids have fixed shape, whereas movement of particle is allowed in liquids and gases. As a result, they do not have fixed shape. They changes their shape according to the container. This is a shape is a next property of matter. So different physical state of matter have different like possibilities of having variable shapes. Like solids do not changes their shape. Their shape is fixed, whereas liquids and gases changes their shape. Now let us discuss another property of matter. Yeah, we discuss the next property of matter is its volume. Right? What is meant by volume? Is the extent of space occupied by matter is called its volume. Right? It's called its volume. For example, just imagine when you sit in chair. Can somebody else come and sit in same chair? It's not possible, right? Right? In order to make sit other person in the same chair, first we have to get up from the chair, because when you are sitting, that space is already occupied by you, so some other can't come and occupy the space. Yes or no? So like that, every matter occupies space, right? For example, another example we'll see, to fill medicine into syringe, like we fill water into syringe sometimes, to fill it, right? What we have to do first the air inside the syringe has to be removed, right? Then only we have to fill the medicine. Let us see a common observation, right? Common observation. If I want to fill water into empty bottle, if I immerse the empty bottle into the water, what happens? We see when you immerse empty bottle into the water, empty the bottle, right? What do you see? We see bubbles coming of it, bubbles of air coming out of it. At the same time, water enters into the bottle. It's like this, if I have, this is all the surface of water, this is all the water, right? This is all the water, right? When I immerse a bottle, empty bottle, right, into the water, when I completely immerse it, then what happens? You see air bubbles come out the water. At the same time, some amount of water, this bottle is gradually fill up with water. So which means The empty bottle is actually not empty, it containing air. Air is a form of matter, right? It's a gaseous state. That air is occupied completely inside space of bottle. Now when I dip it in the water, what happened? To enter water into the bottle, first the air inside has to be vacated. So that air come out, the air come out in the form of bubbles, right? At the same time, the same amount of water enters into the container. Is it clear? So the space, every matter occupies space, right? To fill any other substance into the same space, already the occupying substance has to be first removed, right? Then it is filled with another substance. Now we have different physical states of matter, right? And how about volume occupied by different states of matter? For example, first let's see again what we'll discuss, right? Solids, volume occupied by solids, volume occupied by liquids, volume occupied by gases. Okay, in this video we have already discussed how do we express the volume of solids, liquids and gases. Let's say volume of solids expressed in meter cube or centimeter cube, liquids and gases expressed in milliliter or liter, this gas also expressed in milliliter and liter, generally volume expressed. Now let's see, it's like simply occupying space. Now let us consider solids. Do solids occupy always a fixed space? For example, there is a table in the room. There is a table in the room. Is that table occupies the same space every day? Right? Or one day it occupies small space, one day it occupies large space. Is it like that? No, right? The table, since it is a solid, it doesn't changes its shape. It doesn't changes its shape, and it always occupy the same amount of space, like it has same volume. So we say solids have fixed volume. Each solid has its fixed volume, right? Volume, we understand the volume from its size, or like, we understand. Solids have fixed volume, right? They always occupy the same space. If I have a table here like this, like we have a table here, this table always occupies the same height, the same length, the same breadth. Okay, it occupies all the three dimensions, always equal. Every day it occupies the same space because they have fixed volume. And why do solids have fixed volume? This is the reason is same as I told you already. If I take the solid, in solid how the particles are very closely packed. Can they move? They cannot move. Since particles of solids are very strongly attracted, they can't move, and they also cannot escape out, right? Particles of solid can't escape from it. Why? Because of strong intermolecular forces. Intermoleculars are very, very strong, forces are very strong. Because of that, the particles cannot move and cannot escape. They cannot move, so they have fixed shape. They cannot escape, so that the volume is also always fixed. Now coming to the liquids. Do liquids have fixed volume? Fixed volume? Yes. So liquids have fixed volume. Liquids have fixed volume. Their shape is not fixed, but volume is fixed. Because if I take a liquid, the particles are attracted by some attraction forces, right? The attraction forces are, these attraction forces are weaker than that of solids, but stronger than that of gases, right? So they are moderate. Okay, in solids attraction force are very strong, in gases attraction force are very weak. How about liquids? Moderate, like in between the solid forces and the gaseous forces. They are weaker than solids but stronger than gases. So because of these moderate attraction forces, the particles have spaces, they can move within, but they can't escape. They can't escape. These attraction forces are not strong enough to hold the particles tightly. Not strong enough. So particles can move. But the attraction forces are strong enough to avoid escaping the particles. So these particles can't escape. So liquids have fixed volume. They can't escape for fixed volume, right? For example, if I take 1 liter water, 1 liter water, right? Maybe in different shapes, right? Let's say this is 1 liter water, right? In a bottle, if I take this bottle also contain 1 liter water, right? The same transfer. If I transfer this into a glass, okay, which is also 1 liter, for example, right? So the shape changes according to container, but volume, this is 1 liter, this is 1 liter, this is 1 liter. For example, if you get 1 liter milk, you take into a bowl, will it become half liter? Will it become 250 ml? No, right? It remains 1 liter. 1 liter is a volume of milk that you take, and that 1 liter remains fixed. So all liquids have fixed volumes, same as that of solids, but shape different. Solids have fixed shape, liquids do not have fixed shape. Now coming to gases. How about gases? Gases do not have fixed volume. Their volume also changes, right? Why volume changes? Because if you see gas, the attraction forces are very weak intermolecular forces. These weak intermoleculars are very weak, so that they cannot hold the particles in their spaces, but also they cannot hold them to escape. Okay, it cannot stop them to escape. So particles of gases can escape. So that what happen? Volume of the gases differs. Volume, they do not have fixed volume. Is it clear? They do not have fixed volume. Another property of a matter is diffusion. What is diffusion? Diffusion is the spontaneous movement of particles of matter. Spontaneous movement of particles. I already told you what is spontaneous. Spontaneous means without any cause. If something happens itself is called spontaneous. And what is happening here? In case of matter, some particles of some matter, it can move spontaneously. That spontaneous movement of particles of matter is called diffusion. Like in the earlier case we discussed, water, when it is taken, okay, in a pollen grains, a drop of water is added to pollen grains and observed under the microscope, right? The pollen grain movement is seen. It is because water molecules are moving spontaneously. So that spontaneous movement of any matter is called a diffusion. Particles of any matter is called diffusion, right? Now, this diffusion we observe in our daily life in many ways, okay? For example, when we are moving, okay, nearby a dumping yard, when we are going nearby a dumping yard, we get that smell, the bad smell, that foul smell we see. How do we get that foul smell? Generally, in such dumping yards, different gases are produced, and that gases, they, because of their spontaneous motion of the particles, like because of diffusion, they mixes with the air, and in that airflow it reaches all the surrounding areas. So when you are moving nearby the dumping yard, when that smell, that bad smell, foul smell reaches you, we get that smell. It is possible because of diffusion. And now let us see, if you spray perfume in the room, that scent particles move themselves throughout the space available and we get the fragrance. It is also possible by diffusion. Let us see examples of diffusion. Okay, it's spreading the fragrance of perfume, spreading the fragrance of perfume. Okay, or uh, movement of water. Water is nothing but its flow, right? It is all because of diffusion, right? And how different types of matter shows this diffusion. Let us see solids. Solids. Do solids undergo diffusion? Do solids undergo diffusion? They are, in case of solids, the diffusion is least, and that is very slow. The diffusion is very slow. For example, if a plastic scale, let us take a plastic scale. An eraser is placed on a plastic scale. This is a plastic scale. This is a eraser. Okay, eraser. If eraser is placed on a plastic scale, and if it is kept for few days without any disturbance, after few days you see that the eraser completely stick to the plastic scale. It is because particles of scale and eraser, they just intermix with each other, and that takes long time. So we say this diffusion in solids is very slow process, right? In case of liquids, if you see, in case of liquids, their diffusion is moderate. The diffusion is moderate, okay, and this happens quickly. Like moderate diffusion, liquids diffuse with another liquids, like liquids diffusion of water in alcohol. We say consider diffusion. So in case of liquids, the diffusion it takes place, it is moderate diffusion. In case of gases, gases are highly diffusible, right? So they undergoes diffusion to a larger extent of diffusion in gases, okay, larger extent of diffusion. So this diffusion of gases is a very important phenomena, right? For example, we see various examples of diffusion. This is one of the important frequent questions comes in a board exam, right? Diffusion of gases. Example, let us see O2 gas, oxygen diffuse into water. Oxygen diffuse into water, right? In water bodies, right? The aquatic animals, plants, okay, animals present in water, like they need oxygen, and they get oxygen which is diffused into the water from the surroundings, right? Next, carbon dioxide, CO2 diffuse into water. Carbon dioxide is also a gas that is also diffused into water. Then the important biological phenomenon, if you see, diffusion of oxygen, O2, okay, diffused from lungs to the blood, right? Oxygen diffuses. The air that you breathe in that contain oxygen, that oxygen goes to lungs. From lungs it diffuses into blood and makes the blood to oxygenated blood. The next, we go to CO2 gas. CO2 gas also diffuses from blood to lungs. Then from lungs, the carbon dioxide come out when we exhale. So this is a diffusion of a matter. How solids diffuse, how liquids diffuse, how gases diffuse, right? Solids diffuse very slow with each other, right? Whereas solids diffuse faster into liquids. So we'll write solids diffuse into liquids. Solids diffuse into liquids, whereas liquids diffuse into other liquids, right? Like water in alcohol, like that. Then gases diffuse into liquids, Okay, like the examples that we have discussed, CO2, oxygen, these are the gases. They diffuse into water, blood like liquids. Gases diffuse into liquids, right? They also diffuse into gases, also diffuse into other gases. Other gases, for example, when LPG, like when the gas stove is on, when it is not lighted, we get the leakage. When LPG is leakage is there, and that leakage we identify by the smell of the LPG. So that LPG smell we see because of diffusion. Okay, so that LPG, when leakage is there, that LPG gas diffuse into the air, and that air when reaches, we smell it, we understand that the leakage of LPG, it is possible because of diffusion. So LPG is a gas, and that enters it, that diffuse into air, air is also a gas. So solids diffuse into liquids, liquids diffuse into liquids, whereas gases diffuse into liquids, and gases also diffuse into other gases. Okay, this is another property of matter which is called a diffusion, right? Now we'll discuss another property of gases.